Hi everyone, it's Jeff from Transient Specialists. Thanks for joining us today. Today we're going to be spending some time on coupling decoupling networks, commonly just called CDNs. These devices are commonly used for conducted RF immunity testing to IEC 61000-4-6. We'll start by going over a little bit about these injection devices. Then we'll take a look at a few different CDNs, and finally we'll walk through how they're used in testing with our TESSEC NSG 4070. Coupling decoupling networks, as the name implies, are designed to inject the signals onto the associated lines and subsequently remove them, ensuring none of the connected equipment or auxiliary equipment is also exposed. This is one of the most commonly used injection methods for conducted RF immunity testing and is most commonly done in accordance with IEC 61000-4-6. This video is meant to supplement the video we did previously, which I'll put a link for in the description below. Let's go ahead now and let's spend some time on the applications and the rules for selection. Now we're taking a look at the brochure from Ametek CTS for coupling decoupling networks for IEC 61000-4-6. We have some common applications on the left, as well as their corresponding frequency ranges, and on the right, the rules for selecting the injection method for IEC 61000-4-6. As you can see on the left, CDNs can be used for both emissions and immunity testing, with the most common of these applications being IEC 61000-4-6, covering from 150 kHz to 230 MHz. Taking a look on the right now, we have the injection method selection guide. We are most interested in the CDN injection method and the corresponding CDNs that are used. As you can see, depending on the cable type, different CDNs are used, and each grouping has an associated letter. If we scroll down now to the next page, and we open up our window a little bit, we can see the different CDN types, and then the different applications right next to it. Each one of the different CDN types is typically broken down further based on the particular requirements of the application. This is commonly seen with the M-type CDNs, with M1 being for one power line, M2 being for two, M3 being for three, and so on. Let's go ahead now and let's take a look at some common coupling decoupling networks. Taking a look now, we have a few different CDNs. Starting on the left, we have two three-phase CDNs designed for 5 lines. The first of which is the TESSEC CDN M5-100S, which is also the largest, able to handle up to 500 volts AC, 100 amps. Next to that, we have the EM-Test M5-32A, able to handle up to 400 volts, 32 amps. Next to that, in the middle, we have the Fisher FCC 801 M2 M3-16A. This CDN can be used for either 2 or 3 lines. This is atypical as most of the time CDNs are designed for a specific number and type of line. As we look on the right, we have 2 CDNs designed for data lines. The first, the EM-Test AF4, is designed for 4 unscreened, unbalanced lines carrying low current. All the way on the right, we have the ComPower CDN-T8SE, designed for testing shielded RJ45 cables. One thing unique about the ComPower CDN is that it can either be used as an impedance stabilization network for measurements or as a traditional conducted RF immunity coupling decoupling network. Regardless of the type of CDN, a common mode or shorting adapter will be used during the calibration. Let's go ahead now and take a look at the accessories that are used with the coupling decoupling networks. Alright, now we're taking a look at the side of the EM-Test CDN M5-32A. This CDN is designed for testing three-phase equipment and would be connected to the input power going towards the equipment under test. The power input would be going into one side of the CDN and the output going towards the EUT connected to the other side. The connection on top will be going to the amplifier output on our NSG 4070, and we'll walk through more of that setup here shortly. The accessories can vary slightly based on the application and type of line. However, we'll include a shorting adapter and 50 to 150 ohm adapter. As you can see, we already have the right side set up for calibration with our adapters. Taking a look on the left now, all the way on the left, we have our R100N impedance adapter, and this model is from EM Test, designed for our CDN M5. This has a connection on one side which will go to our shorting adapter and a BNC connection on the other. Next to that we have our shorting adapter, and it's designed for the associated CDN and should be ordered along with the CDN and the 50 to 150 ohm adapter. When we're conducting the calibration, we'll go ahead and we'll slide our shorting adapter in the slots, just like that. Next, we'll go ahead and we'll put our 50 to 150 ohm adapter connected right there. We'll also need a 50 ohm termination load on one side prior to running the calibration. Without the correct accessories, it is not possible to run the calibration, preventing testing from being conducted. It is recommended to order the accessories with the CDN, which are typically offered as a kit or package. Let's go ahead now. Let's take a look at the calibration setup using the NSG 4070. Now we're taking a look at the calibration setup using the TESIC NSG 4070. Let's go ahead now and let's start from the left and let's work our way right. Starting all the way on the left, we have our 50 ohm termination load connected to our 50 to 150 ohm adapter. The 50 to 150 ohm adapter is then connected to our shorting adapter connected to the coupling decoupling network. This is done on both sides of the CDN, both the power input and output going towards the EUT sides. On the right side of the CDN, we have that connected to the channel 1 on our power meter. And then finally, we have the connection on top of the coupling decoupling network to our 6 dB attenuator, which is going to the amplifier output on our 4070 test system. Let's go ahead now and take a brief look at the test setup. Alright, here's our test setup. When running the test, the system will apply the calibrated levels to the cables connected to the CDN. Looking at the setup now, we have removed our shorting as well as our 50 to 150 ohm adapters from each side, and we have left our 6 dB attenuator as well as connected it to our amplifier output. Alright, that should complete the video today on coupling decoupling networks used for conducted RF immunity testing. We began by going over a little bit about them, then we moved to the different CDNs, and then finally we spent some time on how they're used in testing. We hope this video has been useful, and please keep us in mind if you ever need to rent CDNs and conducted RF immunity test equipment.